Okay, guys, this is, gosh, doggone it. I wanted to get my coffee. Oh, it's more than an arm length away. So I will have it after I do this video. This was a short one. Yeah, so these are parametric equations. What we're doing here is we're describing motion in terms of t, in terms of time. So normally we have like a coordinate plane with an x value and a y value. But this time, one of the axes would be the time. And then we describe the motion that's happening. So well, I'll show you. I'll show you with some graphs here what that would look like. So for instance here, let's say we said sketch the curve represented by the parametric equations. By the way, when we say you have one rectangular equation, right? Y equals, let's just say, let's do it this way. Y equals mx plus b. And there it is, y equals mx plus b. That's a line, and it has y equals m. It's one single equation. But parametric equations, they describe motion in terms of time, t, and it's what is happening to x in terms of t, and separately, what is happening to the y value in times of t. So when we say parametric equations, usually it says a set of parametric equations. It's usually how it's often written. I think in the instructions in the book, it's written that way. A set of parametric equations, meaning the two equations, one for x and one for y. And keep in mind, we live in a three-dimensional world, so we're just talking kind of in just a plane here, but we're gonna stick with that. Okay. So here it says sketch the curve represented by the parametric equations. I should probably write those down. By the parametric equations, x equals the square root of t in time, and y equals 1 minus t. So let me show you that. You share. So if these are my two parametric equations, and I want to graph this motion, what I'm going to do is I'm going to do t, x, and y. And remember, makes sense too, right? We can't talk about what happened. Let's say I'm holding a rock, and then I let it go, and then we watch that rock drop, right? Well, if I say, where's the position of the rock at -3 seconds? That's really, I mean, it's not completely nonsensical because it's still in your hand, right? You haven't dropped it yet. But we don't really talk about its motion until time 0. Once time reaches 0, now we can, let it go, and then we can talk about what happens after time 0. So in general, we don't let time be anything. You could, it's possible. I shouldn't say that, but in general, we don't. So let's go ahead and say when t is 1, when t is 2, when t is 3, when t is 4, and just for grins, because I already know what's going to happen here, let's go ahead and say when t is 9. We'll skip 5, 6, and 7, but we can do more, of course. All right, well, let's do it. Figure out what is x in each of these cases. When when t is 0, x is 0. When t is 1, x is 1. When t is 2, it's the square root of 2, which I think is about 1. If I'm wrong, you guys, I'm just going off memory, which I think is about 1.4. When t is 3, that's the square root of 3, which I think is 1.7. This does not count. If I'm wrong, this does not count as an extra credit point. If it's not that, here, I got a calculator. I'll do it because I just know this could be a problem. Square root of 2 is 1.4, and the square root of 3 is 1.7. All right. And then the square root of 4 is 2, and the square root of 9 is 3. And now let's do y. So this is going to be 1 minus 0 would be 1. This would be 1 minus 1 would be 0. This would be 1 minus 2, -1, -2, -3. This would be 1 minus 9, -8. Okay, so if I plot those points, and I thought I screwed up, but I had not, that point should be at 8. So if I take that table, of values, and I plot the x and the y coordinates for this, so I plot 0, 1, 1, 0, 1.4, -1, Here's what we get. We get this thing right here. And there's kind of a glare. It's the red, by the way. It's the red. And you can see this is motion like something being dropped. So it's going, it's going speeding up. It's going exponentially down faster and faster. It's accelerating down. Okay. Now, of course, we know in real life, there's things like terminal velocity because of the wind and slow down. But we're gonna pretend like this was being dropped at some altitude above the moon or whatever. There's no, wind to slow it down. So that's it. That's it. Now let's see. I think there was something else potentially. That's what it would graph like on the coordinate plane where this is X and this is Y. And just give me a second. I don't want to do stop share. I want new share. Hopefully I can get the right one. It is this one. It says, then write the parametric equations as a single equation. Got it. So let's go back to this. Let's go back to this. And it's pretty simple. So we're trying to write this as in terms of one equation. Instead of X equals in terms of t and what Y equals in terms of t time, we're just going to write one single rectangular equation, right? One rectangular equation, which is Y equals some X, right? So here we go. So this is Y equals 1 minus t. And then we can solve for t here and substitute. So if we square both sides, the x squared equals t, and then we can substitute for t right here. We can substitute an x squared. So this will be y equals 1 minus, again, for t, we're going to substitute an x squared, which makes perfect sense. Let's go back to it. This is y equals negative x squared plus 1. So if you think about it, this is a parabola, right? Just this x is squared. If you want to write it this way, I don't think you should have to. The vertex is at 0, 1. Excuse me. Yeah, let's write it this way. Is at 0, 1, and it's going down, right? It's a parabola that goes down, and sure enough, that's what we have, right? Vertex at 0, 1, it's going down. Makes perfect sense. Okay, let's look at another one. Second one we have as an example is this one. So this one, it says again, I don't have to, I think I will write it in terms, because it's so ridiculously easy. I'll write it as like I'll pretend like it was the same directions as this one, to sketch the curve and then write it as a single rectangular equation. So we're looking at number 37 here. Let me write it down quickly. It's too easy. X equals t and y equals the square root of t. I'm going to think you're going to be better served, I could be wrong, than rather than these examples from the homework, from me when I go through all the problems from the homework to see, to see those answers. Anyway, here we go. All right, so I almost started to make the table without switching over. Share. There we go. All right, so again, what I'm going to do is I'm going to make a table like this with t, x, and y, and we're going to say when t is 0, when t is 1, when t is 2, when t is 4, and when t is 9. I'm going to skip some because I know when t, I'm going to be taking the square root here. In fact, let's get rid of that one and just graph those other points, okay? Well, when t is 0, x would be 0. When t is 2, x would be 2. And when t is 9, x would be 9. Excuse me. And let's get rid of that. I got rid of the wrong one. I meant to get rid of this one. Square root of 2. Keep 1. So let me write over here. When t is 1, x is 1. And when t is 4, x is 4. And when t is 9, x is 9, right? Just x equals t. And then when t is 0, square root of 0 is 0. When t is 1, square root of 1 is 1. When t is 4, the square root of 4 is 2. And when t is 9, the square root of 9 is 3. And if we graph those points, we take this, we graph on the coordinate plane. We go 0, 0, put a dot, 1, 1, put a dot, 2, put a dot, 9, 3, put a dot. What we end up getting is this green one this time, which looks like this. And if we did want to write this as a single equation, pretty simple. All we have to do is substitute for t in terms of x. Well, what is t? t equals x. T and x are the same thing. So everywhere I have a t, I can put an x instead. This is just y equals the square root of x. And sure enough, that is the paragraph for y equals the square root of x. That is the paragraph for it. And it looks like that, right? So over 1 up 1, over 4 up 2, over 9 up 3, over 16 up 4, and so forth. Okay. We got one more here to do, but it has multiple parts, but pretty simple. All right, so it says find a set of parametric equations. Get this here. So if it's y equals 3, the rectangular equation, y equals 3x minus 2, and we're going to do part A is t equals x, and part B is going to be t equals 2 minus x. Okay. So remember what we have to do. We have to get two equations, two parametric equations, a set of parametric equations. One is x in terms of t, and the other one is y in terms of t. Pretty simple. Watch this. So for part A, what is x in terms of t? Well, I think all I have to do is switch the order. That would be pretty clear. There's x in terms of t. So let me box that. One of your two parametric equations, pretty simple. What about y? Well, y in terms of t is all I have to do is substitute for an x, whatever x is in terms of t. And x in terms of t is just t. X equals t. So everywhere I've got an x, I can put a t instead. It's simple. Really, it is. Sometimes they're so easy, you can't believe it, right? Now, this one is a little bit harder, but not too bad. So this time we have to write x in terms of t, which would be pretty easy. We can go ahead and add an x to both sides. The x plus t equals 2. And then subtract a t from both sides, and we get x equals 2 minus t. And let me box that. There's x in terms of t. Now we're going to go back up here, right? Now we're going to go back up here to y, and we got to get y in terms of t. So if we do y in terms of t, that would be my set of parametric equations. This is what you're going to, in the year 2022, this is what you're going to have to do. One of the two questions, parametric equations you're going to have to do. It's going to be y equals 3x minus 2, right? All I do is rewrite it right here. And now we're going to substitute for x, what x equals in terms of t. And what x equals in terms of t is x equals 2 minus t. So it's going to be y equals 3 times 2 minus t minus 2. Now the algebra is pretty easy. It's going to take 2 steps, distribute 3. Y equals 6 minus 3t minus 2. That's going to be y equals negative 3t, and then 6 minus 2 is 4. And kabam, there's my other equation. So these are my set of parametric equations that they asked me to come up with for B. That's it. Okay, that's it. Very short one. Let me go back to here. And here is the homework problems. You can hit pause. I'm going to go away from this pretty quickly, and I will catch you in class. Okay, and I'm going to make another video here in a second for those homework problems. I can stop if I know how to stop this thing.